Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in our previous session related to confidence interval, if you remember, we work on the function of confidence interval, which was based on z-score. And there we have learned that if the standard deviation is given and the sample size is larger, then it's better to use this function. Why? Because in this function, it's based on z-score, where the standard deviation must be given and the sample is larger. But if you have a situation where the standard deviation is not known and you need to compute it from the sample data and also the sample size is lower or less than 30, right? Then it's better you should use this function, which is based on t-statistic, dear students. The difference between these two functions, dear students, here we have the z critical value and here we have t critical value. Z is based on the data where there the standard deviation is given, and if the standard deviation is not given, then you should use the t statistic or this function. Okay, in our situation here we have an example. For example, we have 10 students and each student has a GPA. Okay, now we just try to find out the confidence interval, right, based on 95%. What is the confidence interval where the true average GPA lies in between? This is really important, dear student, in our example. Okay, and most of the time we are interested in this situation. Okay, for this we are using this function. Why? Because here the standard deviation is not given and we need to compute it from the data. Okay, in this function, dear students, we need some certain information, and first for doing this, okay, we need x bar and we need, this is very much related and important information, which is the t critical value, dear students. Okay, have to find out information. First we need to find out the x bar, so equal sign, and just take the average value, simply the average value of all the GPA you have, simply. Okay, then the standard deviation. For the standard deviation we have a function standard deviation dot stdev dot s should be taken. Why? Because this is a sample data. Simply, the next information we have degree of freedom. Okay, very much simply, dear students. I'll discuss inshallah. I'll teach you what is the degree of function, but straightforward here for this case, the degree of freedom is just n minus 1. What is n equal size? This is our n, right? And from the n minus 1, that is giving me the degree of freedom. So in our situation, example, the degree of freedom is 9. Very simply. Okay, the next information here, look, T alpha over 2 and degree of freedom. We found degree of freedom, the next alpha over 2 is required. Okay, if we just try to find out the confidence interval based on 95%, then the alpha is 1 minus 95%, which is 0.05. And in another situation for T critical region or value, you should find out alpha over 2. And this is alpha over 2, equal sign, and this alpha should be divided by 2. Okay, here is a question, dear students. Why alpha over 2? Why? Because we just try to find out the confidence interval. If you remember that, for example, a normal distribution, this is a normal distribution, and just we try to find out the confidence interval which is in between. This is interval. Okay, this is lower limit is here, for example, in upper limit, and just we try to find out this space, this interval. So that is why when we just try to find out the lower limit in upper limit, so that's why the alpha should be divided by 2. Okay, this is really important. Okay, okay, just let me remove this back. Okay, students, now in our example here we found out the alpha over 2. This is also in the t critical value required in the degree of freedom also. Now we need to find out the critical value, and that should be found out using these two informations. So the intersection of degree of freedom in alpha, this should be taken from the table of t distribution, which is all called t students table. Okay, okay, dear students, we have a table where the table is called the t distribution. In this table you should find out degree of freedom. In our situation, degree of freedom is 9, and then you should find out the 0.25 in degree of freedom, and this is exactly the value. Why? Because in the intersection of 9 degree of freedom and the alpha 0.25 is 2.262, 2.262. So we found out 2.262, dear students. Okay, very simply. Okay, the critical value is just found from these two information. So we found this very much important information, this which is the critical region or critical value for this formula. Okay, we found it, and you can just find it using the same function. Okay, now next, dear students, one more information I just tell you, that if you just straight away find it using Excel function and do not use table, do not use these two information, then we have a function for critical value equal size, and just type t inverse. We have T inverse. This is T inverse dot 2T. Okay, and just here, what is the probability? This is a probability in degree of freedom. Put the plug in degree of freedom, and this is just giving you directly the critical value. Keep in mind, dear students, if you do not use the T distribution table, right, then you do not need this information, degree of freedom and alpha over 2. Why? Directly you can take this using Excel function. Okay. Okay, now dear students, once this information is given, just plug it here and you can find out the confidence interval. Okay, for this confidence interval, okay, we have x bar and this value. Okay, we need to find out the marginal error. Okay, to make it simple, this whole area, this is what is called marginal error. Okay, this one. How to find the marginal error? Okay, first we find out marginal error. Okay, then equal sign for the marginal error. If you just do it manually and do not use Excel function, then first you have T alpha over 2 degree of freedom, which is the critical value, and we already found it here. And then next is multiply. You should multiply this into standard deviation. Okay, what is this is standard deviation, and over the standard deviation should be divided by square root of n. Okay, the square root of sample size. This is the square root of n, and this will give you the marginal error. Okay, once the marginal error is given, then you can find out the lower limit and upper limit, student. Okay, very simply. How to find it out? Equal sign. Okay, look for this confidence interval. If you just find out lower limit x bar, this is our x bar, mean value is x bar, and for lower limit you should minus the marginal error first. Marginal error should be subtracted from. And for upper limit, again, this is a mean value, and you should add the marginal error with this is our marginal error. Okay, the marginal error is this one. Okay, we found out these are the two upper and lower limit we found. Okay, very simply. Okay, yes, yeah. So you can just type it this way: the confidence intervals. The confidence interval we found here is the lower limit, which is 2.88 and 3.22. What does this really mean, dear student? It means we are 95%. We are 95% confident that the true average GPA lies in this range. Okay, this is the range. This is the central value, and this is the interval which is built around the central value, you can see. Okay, and this interval is based on 95% confidence interval. Okay, we say what is the interpretation? We can say the average true value is in between this range, and for this we are 95% sure. We are 95% confident, right, that the average true GPA that is in this range. If you repeatedly sample the GPA of the student many times and construct its confidence interval, then the confidence interval will include 95% of the average true mean value. This is really important, dear students. Okay, hopefully you have learned this. Okay, once more, for example, to make it very much simply using Excel, this was something just you have learned manually. And if you just don't need alpha 2 and critical value in all these informations, what is the direct function? The direct function is just you need to find out the marginal error, okay, using Excel. And how to do that? Marginal error, you should find out marginal error. And now here the marginal error we found out for what we needed some information like critical value and standard deviation and alpha over 2, all these information. But in Excel, we have a function directly for marginal error, and that is confidence interval dot t, confidence dot t. And for z-score, we had confidence dot normal distribution, and here we have confidence dot t. Straight away, just take the alpha value here, and then we have a standard deviation, which is in our example, this is standard deviation, and then size. The size is 10. And press enter, that is giving the same marginal error. Okay, then from this marginal error you can find out what the lower limit, which is the standard deviations minus, you should subtract this to this is the lower limit, and you can equal size within the standard deviation, then you should add this marginal error, that will give you the upper limit. Okay, dear students, this is very much simple and easy. I have just taught you how to do it using Excel function. These are the confidence interval, dear students. Okay, very simply, straight away using Excel functions, built-in functions, just find out the marginal error. For marginal error, you need three informations, just mean and standard deviations and alpha. And once you found the marginal error, then you can find out the lower limit and upper limit very simply, to students. Hopefully, this session is clear for you. You have learned about the confidence interval based on Z score and T score, inshallah. Okay, salam.